College Algebra, Chapter 3, Section 3, Properties of Functions, and the first objective. That was pretty long. The others are similar, though. Determine even and odd functions from a graph. First of all, even functions, we better make sure we remember that. An even function is when the function with a negative value in, say, f of negative x equals f of x. In other words, it doesn't matter whether you put a number in or its opposite. You get the same function value, the same y. That leads us to the idea of symmetry with respect to WRT, the y-axis. So that's what an even function would be. An odd function, f of a negative x equals a negative f of x. Or in other words, if you put in a number, you get a value, f of x. That's the y value. You put in its opposite, and you get a negative y. Here you get the same value, y. Here you get the opposite of y. So that's an odd function, and that leads us to symmetry with respect to the origin. So, if we can see there's symmetry with respect to the y-axis, we have an even function from the graph. If we can see that there's symmetry with respect to the origin, we have an odd function. How would you look at that? Well, let's see here. If we have our friend y equals x squared, and this is maybe the easiest one to figure out because the 2 is an even number. This is an even function, not because of the 2, but because it has symmetry with respect to the y-axis. Every point perpendicular through the y-axis has a mirror image. You can take this and fold it over on the y-axis, and it would match up with that left side, or the right side would match with the left, etc. For symmetry with respect to the origin, if I can draw straight lines here, the best example, the easiest, is y equals x cubed. Here, any point, if you take and run a line through the origin and go the same distance away, you will end up on the graph, no matter which point you pick. So you get sort of this pinwheel idea. So it would be a point right here. And that would be an odd function. And what's nice about that is the exponent x cubed reminds you that that's odd. Not because of the 3 it's odd, it's because it has this symmetry with respect to the origin. So, what is objective 2? Yes, objective 2. It says the same thing. Determine even and odd functions not from a graph, but from an equation. So this is where we use the other definition for even and odd, the f of negative x stuff. So, what do? You replace x with a negative x, and you see what you get. Now, it's either even, odd, or neither. Let's take a function, h of x. That is, we'll say 5x cubed plus x. Now, when you look at this, at least when I look at it, I say, ooh, cube, that may be an odd function. But you really don't know until you check it out. You've got h of x. you need h of a negative x. Well, what does that mean? Put in a negative x every place you see an x. So it's 5 times a negative x cubed plus a negative x, which is, because x cubed, this odd exponent, that'll stay negative. It'll be a negative 5x cubed, and this will be minus x. Now, the way that's written doesn't really help us. What are we looking for? If this is the y value, right? If y equals 5x cubed plus x, the same as h of x, what would if this was even, then we would get exactly the same thing back, and we don't. Well, we want to make it look like this anyway. What would a negative y equal? Well, that's the opposite of this whole thing, 5x cubed plus x, which, if we distribute that negative, we'd get a negative 5x cubed minus x. So we're looking for either this situation or this situation. And this is what we've got. This would be even. This would be odd. So we have an odd function. Now, if neither one of those came out here, we'd have to make sure we rearranged this and used all our knowledge of manipulating these expressions to make sure we never had one of these two situations. But it could be neither. So, what is objective 3? Use a graph to determine where a function is increasing, decreasing, or constant. Let me write that down. Use a graph of a function to determine where the function is increasing, decreasing, or constant. So, where a function is increasing would have to be when it's going uphill left to right. Increasing. Oops, that's decreasing. Increasing. A decreasing function is when it is going downhill, left to right. You always go left to right. So that's what this one is. And a constant is when it's horizontal, left to right. Although that wouldn't make any difference. So if you had, and we'll put an XY axis out here, but it really doesn't matter. You're looking at, let me change colors. You're looking at a graph, so it can be almost anything you'd like. Here's a pretty, let's suppose it does something like this. And we're going to mark this as A. This is B. And this is C. And maybe put a D out here. Okay. I guess we need to start someplace also. We'll call this E because I've started the wrong place in the alphabet. So, from the interval, and you can use open or closed. I guess most mathematicians might use the open. From E to A, is it increasing, decreasing, or constant? Well, that would be increasing, right? from A to B would be decreasing. From B to C would be increasing again. And maybe we go to infinity instead of D. Yeah. Go to from C to infinity. It looks like it's constant. So that's really all we're looking at with that stuff. Now I'm going to sort of squeeze in here a max and min idea, which is objective 4. We're going to locate max and min from a graph. Well, if we go to this graph over here, the A, B, C, D, E, F, well, I guess there's no F. A, B, C, D, E, where are the maximums? Well, this is a maximum. Now, you might say, well, how do you know that's the biggest ever? And that's what a maximum implies. It's the biggest ever. Well, this is what we call a local maximum. We know it's highest locally, close by. So when you look close by, A would be a maximum. When we look close by, B would be a minimum. So it's not just a minimum, but a local minimum. Now, all these points, C through D, would have to be maximums. We really don't use it that way most of the times. It gets to a maximum point from C and goes on. So this interval could be called a maximum, I guess. And if that were the same as the height of A, then they would still be local, because the only time you get a maximum, that if it's the only one that's the highest, if there was a point higher than A and higher than all these C through D's, they would call that an absolute maximum. Let's move E down here. B is a local minimum. E, though, is an absolute minimum. If it is the lowest point on this entire graph, like absolutely, it's the minimum. B is local, but it's not the lowest for everybody. Does that make sense? Hopefully. Objective 5. Use a graphing utility, in our case the graphing calculator, to approximate max-min, increasing, decreasing, constant. Okay, let's see. Use a graphing calculator. You could use software on a computer, of course, to approximate the max, the min, increasing, decreasing, and constant portions of the function. Could be points. Okay. So, if we take a look at our calculator, let me get one pulled up here. Okay, suppose we were asked this question. You've got a function y equals x squared minus 1, where x is less than 2. We want to know, is there a maximum point, a minimum point? Where is it increasing, decreasing, and constant? Now you can do that by hand But let's use a graphing calculator also to make sure you know how to do it on the graphing calculator. When you turn this on, let's get this back to the home screen. Let's clear out the home screen. Y equals, and let's clear that out. There's the clear button below the arrows that I'm going to. And here we're going to put in x squared. Now I'm going to put this in parentheses because of later on. Well, I'll show you what we're going to do. But right now, put this in parentheses. Start with the left paren and then do the x squared minus 1. Close it with the right paren. And there's a reason we're going to do that you'll see in a second. Now you can do a zoom, and the standard thing to do would be zoom standard, or in French, z standard. And that would be your x squared minus 1. It's x squared, that's parabola, but moved down 1 unit. Now, if we want to say, no, I want this to be less than 2. And suppose we were told to do it in a certain window. And they gave us the window coordinates. Go click on the window button. They want to go from a -5 to 10. -5 for x min, 10 for x max. Scale of 1 is good. If you get more than 20 marks on the screen, it sort of blends together. So don't do more than 20. And y min is also a -5 to 10. And a scale of 1 will give you mark every unit. The X resolution, don't worry about that stuff. These first 6 are the important ones. And you can graph that. Now it looks pretty much the same as before. How do you include an x is less than 2 portion of this? Well, that's what the parentheses are for, on this calculator at least. Go back to the x, or the y equals, and after this in parentheses, it's got to be in parentheses because it uses this idea of multiplication, and when you get zeros you don't plot, and if you get other numbers you do plot. So we're going to put also in parentheses, left paren, the x. Less than is located in this test above the math key, which is below the alpha. So we do second math, and here's the test we want less than, which is number 5. And 2, right paren. Now when we graph it, it stops at 2. On the older calculators, the way it doesn't graph is not that it doesn't graph, it moves to the x-axis and plots it there. To show you what I mean, if we go second format, and if I turn the axes off, you don't have to do this, I just want to do it, and graph it, you can see it's really graphing that right along the x-axis, trying not to show up. How do you get rid of this vertical part here? Because that's not part of it either. Well, that's the mode. Right now it's in connected mode. If we put it in dot mode, then it'll graph that. But I think, and the problem there is it puts some space in between some of these. I think with the TI-84, they've taken care of all that stuff. So on mine, you'll probably see some extra lines that you don't see on yours. But I'm going to go back to connected because it's usually the better way to look at these. Anyway, just so you recognize that those vertical lines are really not there. And yours probably does it very nicely. So, if you had to give some values here, how would you do that? Where is this increasing? Well, it goes probably from 0 to this 2. It's increasing. Where is it decreasing? Well, negative infinity, because we didn't start any place. We said x is less than 2. So from a negative infinity up to 0, it's decreasing. Is it constant anywhere? Well, only at single points, and that doesn't make any useful sense for us to graph. Is there a maximum? No, this goes to infinity on the left, and that therefore there is no maximum because infinity Doesn't matter what Buzz Lightyear says, you never get to it. There is a minimum at 0. So because you know some of these values, you can find all that stuff. If you didn't know where this minimum was located, but you knew that that's the spot where you would stop going down and start going up, you'd stop decreasing and go to increasing, then you could find that point. How do you find it? Second trace gets you to the calc menu. You can find the maximums and minimums and stuff. We can see there's a minimum, so I'm going to choose number 3. Now you use your arrows to do the left bound. Go to the left of that minimum point. How far? Doesn't matter. Someplace to the left. Press enter to mark it. Now you've got this arrow. The right bound, use your right arrow in this case to get to the right of that. How far? It doesn't matter. Oh, well, I guess you can go too far, but at least a little bit past it. Press enter, and now marks the arrow pointing to the left. And now it's going to look between these two arrows. They say guess, and it's sort of better to get close to what you want. I'm going to get just a little bit close. You see, it doesn't really matter. It'll find that minimum. And I'm glad this did it to me too. Every once in a while, you'll get a number like this, a negative 2.883e negative 7. Well, this number is really so close to 0 that it might as well be 0. And I didn't want to get close to that point, I guess, when I was doing the guess, so that it might do something like this. And this, though, you've got to read as a 0. It's just so close. It's got 6 zeros and then the 2.2, right? Anyway, negative 1 is the y value. So at 0, negative 1, and you can use those coordinates to help you define intervals for the rest of this. You know it only goes up to 2, and it does not include 2. Now, if you had to draw this then, you've got something you could draw on your homework, oh my gosh, and get 4 steps. So I'm going to go negative infinity down here to a 0, negative 1, and then to 2. So how do I find this point? Well, let's see. If we do second calc again, the value should show you a value at, say, 2. I'm sorry. We need second calc. We will choose number 1, and then you can put in a 2. And when you do that, it says y equals 0. You say, what? It's because we said less than 2. Maybe on yours, it won't even give you a value here. But it might. So you got to be smarter than the calculator. It can only do so much. 2 is not included in this domain. So we need something that would have been, I guess, at 2 if we didn't exclude it. When you plug in a 2 here, you get 2 squared or 4 minus 1. So it'll be at 3 that this would be. So we've got points at 0, negative 1, and almost a point at 2, 3. Does that make sense? Let's draw that. So this is going to come to the point 0, negative 1, and 3. But it's going to be an open circle. So it's going to go down here, come back up. This goes forever. Boy, my lines are not real smooth. I guess it's got to brace my hand a little better. So, where is it? Let's go from a negative infinity up to 0. This is decreasing. At 0, that's 0, negative 1, this is an absolute minimum. And then, now this is a point, right? And this is an interval, so be careful. They look like points, both of them, almost, with that infinity. Maybe not so much. Then we go from 0, these are using x values, right? 0 up to 2 is when it's increasing. I guess this looks more like a point, but it's an interval. We can't really say that there's a local maximum here because we don't know the point that would be right before 2. There is no point right before, well, I guess there's a point, but we don't know what it is going too many decimal places. It's 1.999999999. Does that make some sense? So this can't be a maximum because we can't find a point. Okay, let's see. Increasing, decreasing, max, min, constant. There is no constant. Does this make sense? Okay. Objective 6. The average rate of change of a function. This is the same as the slope of the secant line. You remember secant line in geometry? Okay, let's draw a graph here. If we can do it without too many curved lines here. Suppose we have a graph that looks something like this. We need to choose where we want this average value for a function to be, what interval. And let's choose these 2 points, A and B. Now, this may curve or it may not curve, but there is a line, a straight line, if I can draw it, that connects those 2 points that could give you the average rate of change of a function. This is the secant line. And the slope of a secant line, if you've got 2 points, is found the same whole way. It's the change in y over the change in x. It's the y2 minus y1 over x of 2 minus x of 1. Same thing. So if we're given a function, let's say y equals x squared minus 1 again, and you want to find the average rate of change from a -1 to 3. First of all, what are we looking at? Let's say this is a -1. If we put in a 1 or a -1, we get 0, so we know it crosses here. So it does something like this. And so at -1, we're looking at this point, and at 3, we're looking at this point. So it's really the slope of that secant line. This is the A, and this is the B at 3. So, at A, what are the coordinates of the point? Oh, that's a -1, 0. At B, what are the coordinates of the point? Well, you plug in 3, you get a 9 minus 1, or 8. What is the slope of that AB secant line? Well, that's y2, 8, minus y1, 0, over x of 2, 3, minus x of 1, -1, or 8 over 4, or 2. The average rate of change of the function between -1 and 3, the x values, will give us the slope of 2, the slope of the secant line. And that's all there is to average rate of change. It's really back to our friends, the lines, slope, and just reminding ourselves what the heck we did in geometry. Secant lines. Pick 2 points, draw a line through them. On page 239, problems 21 through 28 have these instructions. We're going to add to this because they've separated that, and we're not going to, all the max and min points in this also. And I've chosen, I guess, number 26, which goes from negative pi to pi. So let's see how straight I can make this stuff. So if this is pi and this is negative pi, here's negative pi over 2, and here's pi over 2. And it goes from 0 to 2. So if this is 2, here's 1, negative 1, and negative 2. We plot ours. Negative pi, negative 1. Goes through negative pi over 2, 0. 0 and 1. Pi over 2 and 0. And pi and negative 1. Okay. This is a trig function that's been stopped, so to speak, at this negative pi and pi. So, if this is pi negative 1, and this is negative pi negative 1, the rest of these, this is 0, 1. Hopefully you can see these are pi or 2 zeros. Getting that 2 filled up. So what are the intercepts? Usually for the intercepts, we only need the x and y values. We don't put points. I'm not sure how they'd answer this in the back of the book. I'll have to look. But the x-intercepts, and I'll put an S here, are at pi over 2 and negative pi over 2. The y-intercepts, the only one y-intercept, is at 0, 1. We don't put the see. The y-intercept is really 1. We don't usually put the 0 for that. We use the x values for the x-intercepts and the y values for the y-intercept, because the other, for x-intercepts, y is 0, and for y-intercepts, x is 0. This should be ints and s. Okay. Let me put down here domain and range. The domain for this goes from a negative pi to pi. So we're going to include those because it's got the solid dots from a negative pi to pi. That's interval notation. And the range in interval notation goes from a negative 1 to 1. And those are included. So if they say in interval notation, make sure you use the square brackets and parentheses. C, where is it increasing, decreasing, constant? So increase. Looks like it's increasing from a negative pi up to 0. I'm going to use just parentheses here. Negative pi up to 0. It's decreasing from 0 to pi. It's constant, not applicable. And that just shows me the greater that you know what you're doing, because you say there ain't none. It's D. Is it even, odd, or neither? Well, let's see. It has symmetry with respect to the y-axis. That's like x squared. That's even. E, are there any maximums or minimums? See, there is a maximum. Is it absolute? It is. At the point 0, 1. Now, many times they just give the x-coordinate for that, a maximum at 0. Minimums, there are two of them. You perhaps could argue that they're absolute since they're both the same, but that means absolute means 1 and only 1 usually. They are at a negative pi and negative 1 and a positive pi and negative 1. So negative pi, negative 1 and pi, negative 1. Two minimums. And that's 4 steps. You can do a lot of these that way. So how do we looked at the problem, the graph, and figured out where things were even or odd. Let's take a look at number 44. Capital F of x is 2x over the absolute value of x. So, we also need, in order to find even and odd, this is what we need here. Even or odd, neither. So, what is f of a negative x? Well, let's see. That's 2 times a negative x over absolute value of a negative x. Well, this becomes a negative 2x over, well, the absolute value of negative x and absolute value of x are the same. So I'm going to replace this with absolute value of x because I want to see how much it matches this. So if I rewrite this maybe even a little bit more and say it's a negative 2x over the absolute value of x, which is the original problem. And that's what you want to see. How is it changed from f of x? Well, this goes from f of x to a negative f of x. And when it does that, that's an odd function. Does that make sense? And now we get to do one of these with the calculator. Let's go to a new screen. Number 52. The function, we're going to use y, of course, on the calculator. Negative 0.4x to the 4th. Minus 0.5x cubed. Plus 0.8x squared. Minus 2. It says over the indicated interval, they want this interval to go from a negative 3 to 2. Okay. Let's put that in. We have our calculator right here. And we go to y equals, clear out the old one. This, use negation here. This, don't use subtraction, use negation, negative. And you don't need the 0.4x to the 4th. Minus 0.5x cubed, x to the 3rd. Plus, this is going to be 0.8x squared. And minus 2. Not negation, but subtraction. So, we need to have the window go from a negative 3 to 2. And I guess we'll just count by ones. Once you get the x-min and x-max, x-scale doesn't really matter. Just want to make one that makes sense with your x-min, x-max. Once you get the x-min and x-max selected, you can use a zoom feature. Down at the bottom, it's zoom fit. And what this will do is calculate for that negative, that x-min and x-max, what fits in the screen. So zoom fit will be working here for a little bit. See that little worm crawling there? And this is what it'll give us. So we can put in here, I guess, -3 to 2, but many times it's better just to see what's going on with that screen. It'll be a little easier sometimes to work with. What do we need here? Well, let's see. We need to find the max, the min, increasing, decreasing. So we need to find these max and min points. There's a maximum here, a minimum towards the middle, and another maximum. This goes back up and back down. So we got to find those three. We know this is -2 and -3 and +2. So let's see here. Second trace, find a maximum, number 4. So we're going to go over here. This is a little bit covered up. To the left of that peak someplace, press enter. To the right of that peak someplace, a little hard to see, but press enter. And then the guess, I don't know, someplace up here. Press enter. So, the minimum is at negative, did they say how many places? 2 decimal places. -1.57 and -0.52. Now it's going to disappear for a second. So this is a max. -1.57 and -0.52. Is it negative or positive? Let's bring that back up and take a quick look at it again. There we go. Okay. Oh, it's -0.52. Okay. Because we didn't see where the x-axis was, it's up here a little bit. We might make that window a little better. For the y max, let's go to 0. And then graph it. Then we can see where the axes are. Okay, that's why. Okay. Okay, we also need another maximum. Let's do the minimum next, though. Second calc. Minimum's 3. We're to the left of that already, so I'm just going to press enter. And then use the arrows to go to the right. Not sure exactly where, but see this little hill here I'm going to go between. And then guess someplace here. They say this is times 10 to the -6th. Okay, that's really 0. 0, -2 is a minimum. Okay. That's 0, -2. Where's the other maximum? Let's bring back our calculator. Second trace. Maximum is number 4 rather. Go to the left here a little bit further, I guess. Mark it. To the right of that peak, someplace over here. Mark it. And you could even just press enter again because it'll look between those two. And we want 0.64 -1.87. 0.64 -1.87. That's a 6. Oh my gosh, made it worse. Okay, that's a 6. Let's 0.64. Okay. With those, we can see, and maybe we should do a quick sketch of this now that we know those points. So I'm going to draw this really quick just to give me something to work with. And also, it's another step. So, it's doing something like this. Here's my maximum. We'll call that A. Here's my minimum. I guess I can call that B. Here's my other maximum. Let's call that, I don't know, C. So, where's it increasing? From a negative infinity, I guess ours is just a -3, up to A. Decreasing, while we're here, I guess, increasing from -3 to A. It's also increasing from B to C. Decreasing from A to B. And from C to 2. When you've got separate intervals, you can get their union by using that union symbol. That should be all they want for number 52. Not bad, sort of fun. Learn a little bit more on your calculator. You should be able to do the rest of these problems. Section 3.3.